All right. Good afternoon. Can everyone hear me? I can definitely hear me, so if I fade away, just yell or say something and I'll speak back up again. I apologize now. I did not backlight screen test this presentation, so hopefully these slides are still legible for everybody. My name is Michael Mendez. I am talking about securing code today, just the basics. I cannot cram that down into you in 50 minutes. If I could, most of us would be out of a job and there'd be no need for the conference. A little background on myself. I am a senior developer. Much like Sam, I've been doing this quite a long time, more time than I would really like to admit to on video. Been writing a lot of code over the years. I first started getting interested in the security aspects of code when I was writing an application as a former life as an emergency manager to share 911 call data with the other emergency managers. Fire side of things is a little old school still. You still see a lot of firefighters with the little pagers on their hips that beep and drive you nuts when you're out at the movies. Technology is still catching up with us. So I was writing a mobile app that would let the first responders see what was going on. You know, is the ambulance en route? Is the chief going? What's the actual call? And I was working with a technical sergeant in the sheriff's department to get access to that data. And we started thinking about the impact of that data being online at all. So that's where this kind of started for me. Since then, a little bit of a life change brought me out here to Cleveland, not developing full time. I've also been an educator for quite a while, so I apologize if I talk your ear off. I'm also a home brewer, so I'm definitely a fan of sibling revelry contributing to today, and I will also happily talk your ear off about all things brewing related, a little out of scope. You can find me on Twitter at RelicScoth. You won't really hear much from me because I really use it to read more than I use it to contribute. Maybe someday that'll change. And email michaelgmendez@gmail. So, securing code. I got a question for you guys. Why are we still talking about this? I mean, really, we have literally decades of guidance on how to do this well. As long as I've been writing code, there's been documentation out there to use, so we don't screw this up. Whatever. I'm lazy. I'm not going to read all of that. Okay, fine. How about the piles of requirements sitting next to you on your desk that some of these carry very heavily penalties and legal requirements that we just happen to ignore? Absolutely. It is that important. No, it's not. Thank you. GDPR, though, is obviously what everyone's focus is on right now, seeing as it went into effect just a couple weeks ago. I ran into this within my own company as we were implementing our solutions and getting everything turned on to be in compliance. Even internally, we had some discourse as to how some of that needed to be interpreted. That resulted not only in internal counsel getting involved, but also outside counsel getting involved, so we could determine what we were going to do as a company and what they considered the risk to be and really what we needed to comply with. And that's just one out of all of these. You know, the jury is still out on what kind of teeth GDPR is actually going to have. It's so new, we haven't really seen anything come out of it yet in terms of somebody actually being confronted with this for being in violation. Maybe within the last week. I haven't checked. I did hear that there were charges the day it took effect. I haven't heard if there's any resolution on that yet, if it can actually be fully enforced. But a lot of these can be. And to be honest, actually, a quick question. Where are my developers at? Okay. Where are my ISOs at? Wow, only one in the room. Well, you're the one I'm targeting today. So this presentation is very much for you. A lot of companies are still regularly violating a lot of these policies. We know it. We don't want to talk about it, but we know it. So where does that leave us when we actually look at our code? Couple studies that have been done. There's been a lot more than this. I just kind of picked a couple out. Carnegie Mellon did a study, 20 to 30 bugs per 1,000 lines of code. Well, if you do the math, that makes 99.98% bug-free. Okay? Another study, specifically on the Linux kernel, found even fewer, 99.998% bug-free. Even better. So why are we worried about this? We're worried about this when it becomes a matter of scale. When you look at Windows 10, which has a common estimate of about 50 million lines of code, now you're looking at 1 million bugs. Are we a little more worried now? Okay, million line of bugs, 50 million lines of code, still not horrendous. It's not great. I'm not going to sleep well. But it gets worse. Last year, in the NVD database of bugs, 32% of those bugs carried a CVSS score of 4 or greater. A score of 4 or greater immediately puts your company in violation of PCI. Doesn't matter if it actually impacts your ability to process credit cards. You're still in violation just by having that vulnerability. It's about a third. Now, I know we still pay a lot of attention to network, and yeah, network is still beating us up in terms of the quantity of problems we have with securing our networks. But software is definitely leading the way in the quality of those bugs and how bad they are when they come out. I just love the dumpster fire gif too, by the way. So, OWASP, the number one thing on OWASP right now, and it's been on the list forever. Injection flaws such as SQL, NoSQL, OS, and LDAP injection occur when untrusted data is sent to an interpreter as part of a command or query. The attacker's hostile data can trick the interpreter into executing unintended commands or accessing data without proper authorization. Everyone get that? Abraham Lincoln, by the way. I don't know if you can see that in the back. What does that actually mean? We blindly trusted something the user gave us, and we put it somewhere important. That's what it boils down to. It has been on the OWASP list as far as I cared to look back, and it's still one of the worst things that gets to us. If you're a developer, you have to keep one key thing in mind whenever you're dealing with something a user gives you. Users are two things. They're dumb, or they're malicious. That's it. That's your assumption all the time. I am constantly reminded of Men in Black with the line of, a person is smart. People are dumb, panicky, dangerous animals, and you know it. That's how you need to live as a developer. Be paranoid, be crazy, worry about it. So, I'm not going to give you guys an overwhelming amount of code examples. Some of you are devs. I've got one ISO buried in the back the last time I polled you guys. Developers, keep these things in mind. I know that a lot of these are going to be familiar to you. I know it's hard to keep this going. The two greatest things, personally, that I think kill us right now in terms of software quality, in terms of security, are minimum viable product and continuous integration. The push in our organizations to have a minimum viable product as soon as possible and keep that speed of business going absolutely kills us because it overrides security, because no one above our pay grade gives a crap. And Then you wrap on that nice little blanket of continuous integration, especially as a developer, because I'm like, well, if there's a bug, we're CI. I can patch it as soon as I see it. I don't have to wait 3 months for a release and worry about it in the meantime. But that's also assuming I'm finding the bugs as soon as I'm creating them. And that little safety blanket of, I'll fix it as soon as I see it, really doesn't mean anything to us. So this particular example is PHP. You'll also see some JavaScript. I'm a web guy. I'm an OpenStack guy, not like Sam, who had all those great tools in VB for us an hour ago. Don't worry about the language. I want you guys to focus on the concepts of what I'm talking about. So in this example, does anybody see something bad? Hint, of course you do. Anybody know what's bad? Rob. Right. So there's actually two things here. The first is the fact that I'm running a function in PHP that is basically giving me shell. Is letting me run things at the OS level. I can call other applications. I can run scripts that I happen to know the names of. Anything. Bad. Just don't do it. If you have any use case where you can get away from doing things like this in your code, do it. Don't even let it be a factor in the first place. Because the moment you introduce a function like that into your code, any exploit somebody finds is running outside of your code environment and on your OS. The other problem with this is that we're passing variables into that script that we're running. What are users? What are the two things about users? Malicious, dumb. Either one of those things can break. So if we're passing variables into something that's giving us OS level access to the machine, we're owned. That's it. Somebody will find it. If you absolutely have to do this, because I get it, there are use cases, there are things you can't get around, you have to drop to this old script because no one understands what the hell it does, but it still works, and we need it to work for the business to work, so I've got to do this. Do everything in your power to make sure you have done due diligence with what you're giving it. You want to make sure that the user that your web server is running as has few permissions as possible on the system. The bare minimum it needs to actually run on the server. Avoid using the user input. If you can get away from that and just have something run on its own, fine. Much smaller worry. And the last thing is clean and validate user-provided data. This is going to be a recurring theme for the next few slides. Another example, nice little form. I don't know how legible this is in the far back, but there's some extra text in here at the top field. It's a basic login form, username, password. Now, bless you, here the extra text is after username, so you guys can see it, and it's not obfuscated as a password field. In reality, we would usually be doing this more on the password side. This is an example of malicious. So this is somebody coming in and saying, you know what, I know SQL. I know how the commands work. I know the language. I'm going to take some guesses as to how you're using the data I give you and putting it into the query. And I'm going to see if I can build my own query. So what this actually looks like when you do it wrong on the back end, stored in the code is going to be the string that is actually your SQL command. And in that, in this example, the email field and the password field are being dropped straight in. So what that means for us is that as this gets passed through to the actual SQL server in the back end, the special characters that our malicious person dropped in change the query. And it's no longer selecting where our username and password are present, because they short-circuited it, and they said, show me where the email is this and the password is this, or if 1 equals 1. How many times is 1 going to equal 1? Always. So what have they done? They're logged in. as whatever they want to be. That's a SQL injection. It is still one of the most prevalent problems today. Why? Because we're trusting people. Panicky, dumb animals. Ourselves included. Present company. So how do we start to get around this? If you're a dev, you've got to do your sanitizing. You've got to do your validation. You've got to do it every time. I know it's a pain in the butt, but it's got to be done. If you're an ISO or you're in any kind of position where you are responsible for reviewing code or should be reviewing code, some key things to look for is that any time you're taking data in from somebody, you're looking for things that clean it up, and then you want to make sure it's still what you need it to be. So as sanitizing, right here we're taking our password, we're replacing whatever comes in, especially for a special character of the single quote. And if we see that single quote in a password, we're going to yank it out. So in our password policy, can we allow single quotes? Yes or no? No, because we're going to yank it out, right? So when you're letting your users create accounts, you got to make sure they're not using these things. By pulling that single quote out, just that one character for this example, you fix the problem. Their SQL injection won't work. They're going to get an error because the SQL that's getting passed is just going to fail, and it's going to say there's a problem with it. After you sanitize, you still need to make sure that what's left still meets your criteria. So if your password policy is it needs to be 8 digits or longer, and you strip out bad characters and it's shorter, it no longer meets what you need, right? The longer the password is, the harder it is to crack. Even if you're using not as great hashing. So, I mean, this is just an example. I'm just kind of giving common situations here. A lot of places you see 8 characters or more. Adoption, and as standards have increased over the years. So, I mean, it's really, password complexity really kicked up 5 years ago, where you started to see more support for special characters at all. We're devs, we're lazy. If it's not a character or an integer that's easy to test for, it's bad. Well, then we started doing special characters, but then the guys on the malicious side of the fence went, oh, well, you know, it's getting really common for them to just, you know, use an exclamation point at the end of a crappy password or all these other little things. So the longer string started to become more popular because it's easier for us to remember. So it's kind of the next counter wave of one side fighting the other. I would absolutely endorse the longer your password, the better. You know, the whole trick today of come up with a sentence that you can just easily remember and inject that and do your capitalization and everything else. Yeah, that's going to be far better. You don't see that supported in a lot of places because their code base is built. We're developers. We're lazy. We don't want to rebuild it yet. So we absolutely have to. So sanitizing. Get the bad crap out of it. Validating. Make sure it's still valid for your actual use case. Make sure an email is still an email. Better is let your database protect you. So from the PHP side of things, there are a set of different functions in PHP. One are MySQL. Don't use it. The second generation that came out was MySQLe, MySQLi. It was another function to make a connection to and talk to your database. Don't bother with it. Skip right to PDO. PDO is a third set that lets you connect and talk to your database. PDO is a very generically written approach to doing this. So if you happen to be a PHP dev and you're using PDO, you can use PDO to talk to MySQL, MS SQL, Postgres. So you already can talk to all of your database formats because it takes the most standard version of the SQL syntax. What helps us here is that we start to isolate things out of our code. Now you see question marks in places of where a couple minutes ago we had email and password dropped right into the string. We've moved those and we're passing those to our SQL database separately. So we're telling our database, this is the string of what we want you to do. Here are the variables we want you to use. And SQL itself does its own due diligence on top of our sanitizing and validating that keeps us even safer. Best situation, do both. Those of you who were paying attention this morning, this is now the second time you have seen the Bobby Tables example today. And there are a lot of reasons to do both that go beyond just us being safe, because I know that's a hard sell. The quicker you can tell the rare, intelligent, on the up and level user that they've made a mistake, the better, right? The better for their experience, smoother things will be, the quicker things will get on. So on your front end, the quicker you can say, you know what, this password's not long enough, the better. Any Node developers out there? None? Okay. How many of you have been on sites in the last couple years where every keystroke you're seeing validations update on the page? That's awesome, isn't it? Built to it. Go that route. You're giving immediate feedback. You're checking and sanitizing and preventing bad stuff from even being submitted in the first place. That's all on the front end. It's great. It's an awesome experience for the user. What happens if we only do that on the front end? Proxy it and submit your own stuff. I got a bunch of hackers in the room. This is like 101 for you guys. I'm going to open up Postman or any number of another example of application that lets me submit stuff to your server as if I used your form. Me as the bad guy, all I have to do is look at your form, figure out the field names, drop in whatever I want, hit submit. I didn't use your website. All that front-end checks that you did, completely useless. So you have to check in the front for your user experience. Check again on the back to make sure you're still protected. So, another one. A buffer overflow condition exists when a program attempts to put more data in a buffer than it can hold, or when a program attempts to put data in memory area past a buffer. In this case, a buffer is a sequential section of memory allocated to contain anything from a character string to an array of integers. Writing outside the bounds of a block of allocated memory can corrupt data, crash the program, and cause the execution of malicious code. Whew. That was brave Sir Robin, by the way. This one is actually no longer, or I should say not currently, on the OWASP top 10. I still say it should be, because it's still really prevalent. Why don't we hear about this much anymore? Well, frankly, first of all, what does it actually mean? We asked for an email. They sent us a novel. Things got worse from there. So there's your normal, plain text translation there. Why don't we see this anymore, or not too much right now? It's really hard. That's why we're all here and we have jobs. If you're on the security side of things, it's hard to do. You are pushing something past its bounds, but you don't even know where those mile markers are to begin with. It's a lot of trial and error. It takes a lot of understanding of low-level code. And it's not easy. It's also very likely that unless you are being hyper-targeted, they're going to give up before they put that much time and investment into getting you in particular. But it's so easy to prevent. that we shouldn't just forget about it. We've already heard a couple times today how people are pulling things out of their toolkit from 10 years ago, and they're rediscovering just how easy it is to use those tools. Because in the intervening time, we all forgot about that exploit, and no one's looking at it anymore. So, don't forget about it. What do? More cleaning and sanitizing. Check your field length. Make your fields only as long as they need to be. That's it. That'll cover you the vast majority of the time. So there's a couple approaches. One approach is if you're expecting an email address and you decide an email address is maybe at the top end 60 characters and that's all you're going to give them, you can either truncate it and say, I'm only going to keep the first 60, I'm going to junk the rest. Or you say, you know what? Tough. I'm not taking it at all. Give me something more realistic. And this is hard to do. I can tell you this is hard to do because I have a moderately long name and I work for a company with a very long domain name. I have not been able to register for certain sites because my email is longer than they think a normal email should be. So there is a trade-off here. There's a little bit of a check and balance. I must be doing great. There's a band playing for me in the background. So you have to make your logical decisions here of what's realistic. Personally, I would trend towards the latter. If it looks bad, it probably is. Ask them to do it again. Give them a nice little form if they are legit. Having a problem? Let us know. Contact us. Give your good users the ability to reach out to you so you can adjust these metrics later. What do we need to check? Everything. Everything that comes from the user, even if it doesn't sound like it's coming from a user. If you're not a developer, you're thinking, okay, I've got to check my form. Yes, absolutely. You do have to check everything that comes through a form. But us hacker guys who aren't using your form can also manipulate different things, like the headers that are coming along with that submission. That's kind of background information. That gives us more detail about where is this form submission coming from. There are hidden fields that you may not see on your browser that we as developers use in the background so we can hide things that we need to know, like the source and where you came from or which page you happen to land on. And we just want that more easily, so we stick it on the form, but we don't put it on the screen. If I'm a bad guy, I can look at your code, I can see those hidden fields, and I can manipulate those too. So shown fields, hidden fields, headers. If you're a dev, you're going to understand these next few a little bit more. Post contents, your get contents, and your cookies. Anything that's not coming from your own trusted data source, you have to be doing these things on. Sanitize, validate, and you have reduced your problems dramatically. Questions so far? I'm surprised I didn't get one question, which is, but I really want to use question marks and apostrophes and quotes, and I do need that. It is valid for my user to give that to me. Okay, fine. Only on those fields. Accept them. But encode them as their actual HTML value. So if you do need to save it and spit it out back on the screen, like you're letting somebody submit a blog or a review or something like that, encode it first before you ever do anything with it. So if they are trying to be malicious, you still shut them down. Now I'm going to pick on my developers a little bit more because I am terrible at this, and I will admit it. I will admit it to the fact that this is one of my applications, and I stumbled across this a couple weeks ago. The bad on me for not doing my own code review on myself before putting something into production. When you're developing and you're trying to figure out why the freaking thing isn't working the way it's supposed to be, what do we start doing? We start spitting stuff out to the logs, right? What are we bad about doing? Removing them when we're done. This one jumped out at me because I'm sure a couple of you will share the sentiment. I usually precede those things with a common acronym like WTF, because that's usually how I'm feeling at that point in the process. And that is actually what caught my eye. Now, I did kind of tweak this one, so it's not actually anything bad. But there's a lot of sensitive information that you can be revealing that you're forgetting about when you're done. Why can't I log in? Why is this not working? Just show me what's actually coming out of the clear texted credentials. Oops. Why can't I get my database connection to work? It's got to be telling me something. Show me the credentials I'm using. Show me my connection string to my SQL server. And, oh, there it is. Oh, I didn't take the comment back out. That stuff lives there. The other piece that was in here in this example was the data that's actually being rendered to the screen. Not as bad, but there may be more pieces of data here that I'm getting from an API than I want my users to see or that they should be able to see on the screen. So you've got to check your code and get rid of all those console logs and error logs that you don't want that would spit out to the browser. So code reviewers, the ISOs, when you're looking at code, if you see console.log, red flag. The only time you should see that is if you're giving your end user an error you want them to be able to tell you about. How many of you have had applications crash and you see error code 1X05533? Yeah, utterly useless to us, right? As an end user. But you call them up and they're like, oh, what code did you get? Okay, and then someone in the background is looking that up in their documentation. The end user gained zero information, but it still facilitates us getting what we need. We don't need to tell them exactly what the error is. We don't need to tell them the important thing or the sensitive thing. Forgot I had highlights on that one. Least privilege. No one in your system should be able to do anything more than they absolutely need to get their job done. So this, now we're getting more away from code examples. We're getting to structural examples. This is an example of that same type of blogging kind of concept. So here we've identified three roles. You're anonymous, so you can basically just log in and read stuff. You're a user, read posts, or reset your own password. Or you're an admin. You can manage accounts, and you can create content. Does that sound good? Nobody wants to answer because they figure there's a trick, right? Is it better than nothing? Better than nothing, right? If this is a blog-style system where your users are giving you content, do you see an issue? If I'm a user, what do I need in order to give you content? Write permission. Where do I have that on the screen? Admin. Oh crap, all my users are now admins. Bad, right? We didn't follow least privilege. So to fix this example, we'd have to split out another layer. Now we have a content creator that sits between our users and our admins. They can do more, but they can't do everything. This happens more than it should. As not so much as an open source guy, but as a just give me an application that quickly does what I need. User permissions come up all the time. There are systems that we use at work where we have more admins than we'd like because they just didn't really structure things right. Not because their developers did a bad job of this, because us as end users are panicky animals. We're trying to use their software in a way it wasn't meant to be used. We're pushing the bounds of it. We're trying to use it a way that they didn't really think people were going to want. Now we're up against that wall. Another common problem, authentication itself. Make sure your authentication is strong. Make sure your hashing is strong. If you're in any type of code review situation and you see MD5 anywhere, shut that thing down. It's outdated. It's easily reversible at this point. There are entire sites online that you can go to and you can put in a hash and get the password back. Or you can put in your password, they'll give you the hash, and then they conveniently add it to their database. It's not safe anymore. The metric has gone up. So you want to make sure that these things are up to par. The older the application is, the more likely you're going to see things like this. Not because the devs did a bad job, it was perfectly valid back then. But it hasn't been touched in 5 years. If you're having a hard time selling that, the newer ones are faster, good for performance, better user experience, time to upgrade. Another thing to keep in mind, architects and ISOs, use only what you need. So everybody remember a couple of years ago when Facebook Messenger first came out and everyone was up in arms because it pretty much asked for every single permission it possibly could on your device. Did anyone still install Messenger? I'm seeing some nods. I still refuse to. I'm sure there's 80 other apps on my phone that do it, though. Only access what you need. On the same side of that, store only what you need. This is a place where I know we're all really bad because it's so common we all do it. Yes. This is very big on GDPR. And actually getting permission to even have the information in the first place is probably the most key provision of it. So you want to store only what you need. Are you ever actually going to snail mail someone that's in your database? Maybe you are. Fine. By all means, get it. If you're not, why are you asking for it? Are you actually ever going to call a user? Why do you need their phone number? Demographics are great. Every marketing person in the world would be screaming at me for not taking that information. Great, I get it. You want demographics. You want to know where your users are. You want to know their interests. You want to know all these things. But you do not have to tie it to their actual user record. Store it somewhere else. Give it a whole different key. Don't tie it together. Your marketing team will be happy, and you'll be safer. Is it available somewhere else? How many of you, for the developers out there, are using something like Facebook or Google or any of the open authentication mechanisms to allow users to register for your site? None? I'd actually say good to that. But if you are and you already have access to that information there, don't also store it in your system. You have access to it. And if it gets breached through Facebook because they logged into your site using their Facebook credentials, it's not your problem, it's Facebook's problem. Much like their laundry list of problems right now. Personal pet peeve. How many of you have applied for jobs at any time in the last few years? You upload your resume, and you still have to fill out every single freaking thing that you already put on your resume. Why are we still doing this? First of all, developers, I know we need to get better at the text reading, and it is a difficult problem to solve. But really, hiring companies, stop. Read my resume. That's why I put hours into it. If you have it, don't ask for it again. Why not? Why not just store the data? I mean, obviously you have GDPR problems, but what about legal issues? Anybody hear about an Alexa case with Amazon where officers were trying to get information off the Alexa because they were pretty sure it recorded the murder? Legit thing. And there was a big court case about whether or not they could access it to get evidence. Now, if they could and they could solve it, awesome for that case. Maybe not so great feeling for the rest of us who have Alexas in our house that are recording all the time. But your company needs to decide their acceptance of that risk. Is recording all of that data on the off chance you might use it worth what it could mean in terms of lawsuits, federal agencies coming to you for data, the pressure to comply with that. We keep hearing more and more companies that have been helping out ICE and had the feel good at the time that they were helping, and then we have things like what happened with immigration in the last couple of weeks, and all of a sudden they're canceling all those programs and trying to pull out of those contracts because of the bad PR. Did anybody consider the PR before they started handing over all that data? Hopefully they did. Maybe they thought it was worth the risk. Obviously they didn't after the fact. This really does go well beyond I'm sitting at my desk and I'm typing out my code and I'm putting a form together. The ramifications of what you're collecting need to be looked at across the entire organization. If your company does not have an ISO, they don't have security teams, they're not thinking about these things, and they don't have leadership in the room talking about risk, you're in a very bad place. Finally, for storing what you need, ask on demand. If you may need something, you have a problem on your site and you want that user, you want to be able to reach out to that user to find out what happened, you don't have to store their phone number from the day they sign up. You need their phone number when they report a problem and you need a means to reach back to them. Store it there. Only ask for it then and only keep it as long as you need it. When that ticket's closed, junk it. You don't need that data anymore. The next time they have a bug, they can tell you what phone number they want to be called at that time. How can we improve our code in general beyond architecture? Is putting ourselves into a smaller box. Developers, how many of you use an IDE? Good. How many don't use an IDE? Where are my notepadders? Use the IDE. Use the add-on tools. Use your code smell tools. Pretty much every IDE out there, regardless of language, has some type of integrated thing or add-on that helps you write code, that helps you review code. It color codes things so you can see problems. It can give you hints like, hey, your spacing's kind of off. This isn't really readable. Does readability have anything to do with security? Absolutely. If I'm reviewing your code and I can't read it, how confident can I be that I'm not missing something? Commenting. How important is commenting in the function of code? In the function of code. I know this feels dirty to say. Not a bit. But we still need it. You need it to look and figure out what you were thinking 6 months ago when you wrote that function in the first place. But you also need it to understand what's going on or what is supposed to be going on. So if you're not using an IDE, please start, especially if you're deving all the time. I know it feels good to get that code written out without any assistance and find your bugs without having to tell you where your bugs are. But your workday will go better, and so will everyone else's. Duplicated code needs to end. I'm sorry, did you have a question? I'm coming up on unit testing, actually. Yep. And if you can't read this one, by the way, in the back, it's code quality measurement by WTFs per minute. The more there are, the worse the code is. So duplicated code. Why is duplicated code bad? I wrote a function, it works, I copied it to 10 other places where I need that thing to happen. Right? 6 months down the road, I find a bug in that function. I fix it. I forget about the 9 other places I've copied it to in the meantime. What do I still have? 9 more bugs, right? Key programming concept that you hear all the time is dry. Don't repeat yourself. Anybody who's doing a lot of functional programming or object-oriented programming is used to hearing this, and this is why. When you find the bug, you fix it in how many places? 1. Bug's gone. No more problem. Yagni. Anybody out there know what Yagni is? I just heard this one recently. I kind of like it. You aren't going to need it. At this point in my career, as I'm kind of transitioning more into information security and less out of development, I'm really focusing right now just on our API. And as somebody building an API, I want to give my dev team every possible tool to make their lives easy. So they can just quickly roll things out. They can ask for whatever information they want. I need to stop doing that. If there's no use case for it, don't proactively build it. You aren't going to need it until you need it. If you roll it out in the meantime and somebody malicious comes across that endpoint that you're not really using and you're not paying attention to, you're not going to find the problem. So this is one of those few times that I'll tell the developers, stay lazy. If you don't need it, don't build it. Dead code. Right along the same lines of Yagni. You needed it at one point, then you refactored, and you moved on to the next project, and you never took that out of your endpoint. Now you have dead code you're not using anywhere. If you're not using it, you're not paying attention to it. Same problem as Yagni. What helps us there? Documentation. Watch your logs and use code analysis tools to try to find that dead code. Unit testing. Unit testing is one of the best things we can do as developers to cover ourselves. And I'm going to ask in a second, but I'm going to guess we might see one or two hands. Who's actually doing unit testing? 2 hands. A couple more in the back. Do you do it everywhere? Probably more in the back than the front, right? Right. So what is unit testing? We're writing code to test our code before we write our code. Okay. Unit testing takes a lot of planning. First, we've got to sit down and figure out what our application is. Then we've got to figure out what we need to actually build the application. And then we're rushing because we want that minimum viable product as soon as possible to get out in front of people. Before your devs start writing code, they need to write tests about what they need to build. So if I figure out the fact that I need a function that adds 2 numbers, I'm not going to sit down and write the function that adds 2 numbers. I'm going to sit down and go, okay, well, what are the best and worst cases? To go back to Sam's example from his presentation with airline tickets, if you should never have a ticket price below $50, you should test that function to make sure it doesn't allow that to happen or that it gives you an error if it does happen. Because then, instead of having to write your SQL to send you an email to tell you what happened when it happened, you've prevented it right out of the gate. So you sit down and you write all the tests you need to make sure that function does exactly what it needs to do every time. It only gives you things that are in bounds. Then you write your code. Then you use your testing framework to test it. You give it all those rules and tests. You give it the source code. It runs its tests, and you get your passes and your fails, and it tells you, hey, it didn't let me put in a ticket price of less than 50, but it did let me put one in that was more than 1,000. It found the problem before you put the code into production. So you fix it, and then you move on. And you keep those unit tests, because as your application evolves over time, and you add more features here and more features there, you may screw up the function. And the next time you run your unit tests before you push your code out, it's going to say, hey, dummy, remember that whole 10,000 limit thing? You're breaking it. Fix it. You prevented the bug from going into your code and getting out the door. Unit testing is huge. We should all be doing it. It's not easy. Developers don't like writing unit tests. They'd rather write the code, move on with their days, and get on to the next ticket. But it needs to be done. Finally, code review. Devs, I'm sure you're all doing code reviews, right? Looking at each other's code, picking on each other, blaming each other in your repos, right? Has to happen. Try to be nice about it, but we've got to keep doing it. The more eyes on the code, the less buggy it was going to see. We saw that way back in the beginning when we talked about closed source versus open source rates of error in the studies. Linux had a lot fewer, didn't it? You know why? More eyes on it. Any questions? Yes. MySQLi fixed some of the problems that MySQL couldn't support as a function call in PHP. It was a step in the right direction for security. But at the same time, PDO was already there. It was a Band-Aid on a problem that shouldn't have existed. So I would say skip it, go right to PDO. You're going to get something more powerful. And if your company ever decides they want to go to a different database, you're probably covered as long as it's a SQL-based database without rewriting your code at all. If you're using MySQL functions or MySQLi functions in your PHP code and they decide they want to go to a Postgres server, you've got a lot of work ahead of you. Any other questions? All right, thanks, guys.